Okay, key to this question is drawing a good diagram. Let's get that sorted out. So it's in a straight line. I'll have everything to the right as positive. We've got an A, we've got a B. Let's transfer all the information across. The acceleration is 2. Usually put a double-headed arrow for acceleration. Displacement from A to B is 66. And the particle passes point B at 17. Single here, so final velocity equals 17. There's a T which is not mentioned, and there is a U which is not mentioned. So you can go down here, right? Probably better to list it going downwards, right? SUVAT. Go ahead and transfer things over that you know. 66, U we don't know. V is 17, A is 2, T is what we're trying to find. So if we cancel this guy out here, SVAT, I think that's S equals VT minus a half AT squared, and everything to the right is positive. So 66 equals 17T minus a half times 2 times T squared. If you do a bit of rearranging, you will get T squared minus 17T plus 66 equals 0. That factorizes nicely. 6 times 11 is 66, both negative. So it's interesting, you get 2 times. T equals 6 seconds and T equals 11 seconds. Now that's a bit strange, right? Because how can you have 2 different times? Usually when you have maybe a quadratic to solve in T, one's negative, which we discard, right, and one's positive. But both of these answers actually make sense. Now I'm going to show you why they make sense. And the key to making sense of this is to understand what might you have been in this situation, right? So if we go with this equation again now and ignore the T, we work out what was the initial velocity for this situation. Can you see over here, if we put on the side, v squared equals u squared plus 2as, 17 squared equals u squared plus 2 times 2 times 66. And when you do 17 squared minus 4 times 66 equals u squared, can you see there'll actually be 2 answers for u? There'll be a positive answer for u and a negative answer for u, and that's the key to this question. So the question is t equals 6 seconds, t equals 11 seconds, t equals 6 seconds, and t equals 11 seconds correspond with these initial velocities for the particle, okay? So for 6 seconds, we can assume that the particle is traveling already in the direction A to B. And for 11 seconds, we can assume the particle is actually got a negative velocity. But when it goes this way, it slows down to 0, and then it loops back on itself, and it starts going in the other direction. So that's just an interesting question where you might be used to having one negative answer for time, one positive, and you ignore the negative. But in this context, both answers have significant meaning.